Okay, hi everyone. Today I wanted to take a look at the concept of dew point temperature and how it relates to local variation in climate. Okay, so dew point temperature. Okay, so dew point temperature is just the temperature at which water condenses out of the air. So there's water vapor in the air, just naturally. We don't see it because it's in its gas state. And if you decrease the temperature, that water vapor in the air can then condense into liquid. And we've all seen examples of this. If you go outside on a really cold day, you see your breath come out of your mouth, and that's the water vapor in your breath. Your breath has a lot of water vapor in it. That's just your water vapor in your breath condensing as it hits that cold air. Okay, so again, so if we have a thermometer, okay, and it's really dependent on how much water is also in the air. Okay, so for example, here's my thermometer. Okay, so for example, in Arizona here, we have really dry air. There's not a whole lot of water vapor, and so you really have to make it pretty cold for dew to form, or for condensation, right? Arizona, I can spell. But areas like that are much more humid, such as like maybe the rainforest, or even just going, to the East Coast, New York, and Washington D.C. are places that are known pretty well to be fairly humid, and so the dew point temperature there, where there's more water vapor in the air, is higher. So, for example, this is not necessarily true, but I was just giving an example. So if you have wetter air, more humid air, your dew point temperature is going to be higher, maybe only 10 degrees, whereas Arizona, it has to be very cold for that water vapor, that very little water vapor in the air to condense. Okay, so how does this relate to biomes and local variation in climate? Okay. So we talked a lot about temperature gradients, right? And a gradient, gradient just means there's a difference between areas, right? With temperature gradients, we're just talking about areas that are, one area is warmer or one area is colder than the other. Okay, so it's all relative. Okay, so for example, we talked about, okay, so what happens when you have cool lands, fairly cool lands, okay, and you have adjacent to water or ocean that is fairly warm. What kind of, whoops, not warm, sorry, I can't spell and talk at the same time, fairly warm. So what is this climate going to be like? Okay, so well, the air over the ocean is also going to be warm, right? Okay, and if it's warm, there's probably some evaporation going on. So water over the ocean is turning from liquid to gas form, and so the air over this ocean might be fairly wet, okay, fairly humid, lots of water vapor. Also, warm air can hold more water vapor than cool air. Okay, so if you imagine this is the air over the ocean, and as it moves over the land, if it hits this cool land, it's going to start cooling down. So if it starts cooling down, it's going to it's getting closer and closer to its dew point temperature, and if it hits that dew point temperature, then it can condense, right? It can turn back into, it can go from its gas stage to its liquid stage, and it can precipitate out. This leads a lot to temperate rainforests. You see temperate rainforests, for example, in Washington State. So if you've ever been to Seattle, you know that rains about 300 days out of the year. And they have these really amazing temperate rainforests, and that's because they have this gradient of temperatures. They have a relatively warmer ocean next to this cool lands. Okay, so what if we do the flip side of that, and what if we have warm lands adjacent to cool oceans? Okay, so the land is warmer than the ocean is. Okay, well, let's think about the air over here. Okay, so if it's cool, the air is also going to be cool. Oops, I shouldn't have written this so far, but you'll be able to see it. Okay, so this air should also be cool. And again, cool air is going to hold less water, and also there's probably not going to be as much evaporation, so it's going to be fairly dry. Okay, so it's going to have less water vapor in it. So we're talking more Arizona than New York. Okay, so as this cool, dry air moves over the land, is it getting closer or farther away from its dew point temperature? Well, it's getting farther away from its dew point temperature, right? It's warming up. It's going in the opposite direction. It's going in the away from its dew point temperature, right? So it's just going to be warm, cool air. Or sorry, not warm, cool air. Warm, dry air, right? So no precipitation, no condensation, and this is where we get our coastal deserts. Okay, so you can see these temperature gradients from the differences in temperature between the land and the water can really make a difference for the type of biome and the climate that the land is going to have. All right, so let's do our last example, or our last topic that kind of relates to this is rain shadows. Okay, so what is going on with rain shadows and dew point temperature? Okay, so again, so rain shadows occur when you have these kind of coastal mountain ranges, and here, again, let's just say we have some parcel of air, right, and it has some water vapor in it. We're not, and it has some water vapor. So imagine that there's some prevailing winds blowing inland. So as this air moves over the land, it hits the mountain, and it really can't it can't go through the mountain, so it's gonna rise, right? And temperatures at higher elevations are lower, so it's cooler at high elevations than low elevations. So as it rises, this air is going to cool, and if it cools enough, it'll hit its dew point temperature, right? Condense and then precipitate out. And if this mountain is high enough, a lot of times it'll cool to the point where it's lost all its water, and by the time it reaches the top, it's now dry. Right? Okay, so you have this cool, dry air, right? And if the wind's still blowing this way, it's going to continue and potentially even fall in elevation, and as it falls, it warms, and again, it's dry, and if it warms, it's actually going away from its dew point temperature. So it's not going to condense, because first of all, it has lost a lot of its water vapor, so there's not very much of it there to condense, and then as it continues to move and fall in elevation, it actually moves away from its dew point temperature. So this is where you get these rain shadows. So you get these deserts inland. So an example of this is in Washington State and Oregon State. You have these kind of coastal ranges, and so on this side where Seattle and Portland are, it rains quite a bit, but on the other side of the mountains, you actually have these dry inland deserts. And so that's kind of how dew point temperature is really important. It has kind of important implications when you are thinking about local variations in climate.